Yeah, just skip half of it. Thanks.
Good afternoon. Welcome to the Digital Culture Speaker Series. This afternoon, we have a special guest, Biayna Bogosian. Biayna's an academic and professional background extends to architecture, urban design, environmental design, computational design, data science, spatial computing, physical computing, and immersive media design. Biayna's interdisciplinary research has allowed her to understand innovation in design and technology within a broader environmental context and explore data-driven, participatory, and citizen-centric approaches to improve the built environment. Biayna is an assistant professor at the Architectural Technology at Florida International University, an affiliate faculty at FIU's Institute of Environmental and School of Computing and NASA grants. In addition, Biayna is a PhD candidate in the Media Arts and Practice IMAP program at the University of Southern California, in the School of Cinematic Arts. Her dissertation, expected to defend in November 2022, is entitled Exploratory Environmental Interfaces, which focuses on the technical, social, spatial, and political dynamics of working with urban environmental data using interactive, locative, and immersive media. She holds a Master's of Science in Advanced Architectural Design from Columbia University and a Bachelor's of Architecture from Woodbury University. Before joining FIU, she taught at Architecture and Media Arts at Columbia University, at Cornell University, and the University of Southern California. Please join me in welcoming Biayna today.
Thank you so much for hosting me today. I'm very excited to be here and see the work that you're doing and share my work with you. So my training in architecture allowed me to think about the relationship between material and immaterial, and also allowed me to think about importance of designing for people that are occupying the spaces. Here you're looking at two projects, one in the scale of built interaction for series of offices in New York City, and to your left you see an exhibition which allowed the participants to create series of surfaces throughout the duration of an exhibition. So at the core of this has been this desire to understand how we can begin to design for people that are occupying the spaces, taking into account different environmental parameters. So looking at the relationship between qualitative and quantitative, John Tukey, who's one of the most important statisticians in the past decade, has been somebody that I've drawn a lot of inspiration from. John Tukey developed a method called exploratory data analysis, or EDA, which for the first time invited scientists, and this specific case statisticians, which we can start to think about how that then turned into the field of machine learning and what we're calling artificial intelligence today. He invited ultimately the scientists to really open their minds into a different way of engaging with information. And I really, for me, this quote has been quite important in the work that I'm doing. Now, one thing that has also been really critical to my work has been interested in environmental issues. I'm Armenian, but I was born and raised in Iran. A lot of my early memories are memories of being in the south shore of Caspian Sea. So we used to have a vacation home there as a family. We used to go there, but by the time I graduated high school, that entire area was underwater. So the memory of standing in this very specific location, which encompasses a lot of my childhood, and that was underwater, was something that really changed the way that I think about architecture, urban design, and the way that we even think about the built environment. So what has driven my work in the past decade has been these questions about understanding nuanced nature of urban environmental issues, and at the same time start to understand the relationship between data and policy. So this is something that I don't think is a unique approach. It's something that's shared by many, and definitely organizations such as United Nations have put forward not only let's say, the series of principles for us to think about, but also it's really interesting the way that they've introduced series of graphics and let's say taglines for us to begin to associate information and the series of, let's say, policy actions that need to take into effect. Now, history of, I would say, environmental information visualization goes back to people that very early on, the farmers and early scientists that were looking at ways to collecting environmental data. However, modern environmental science is very much also associated with the way that we have been able to develop tools for information collection. And at the core of this has been Edward Keeling, who developed a series of tools for collecting CO2. So what you're looking at here is called a Keeling curve, and it's the single most important information representation in the past, let's say, hundreds of years, that has not only started to mobilize modern environmental movement, but also has triggered a lot of policies and a lot of, let's say, drawbacks. So the same curve, the same data visualization has been used for and against environmental policies. Now, of course, with the introduction of satellite imagery and more planetary way of thinking about information, we are able to, for the first time, start to understand our environment in a much different way. So I remember seeing this visualization, which is a video that NASA released data that they began to collect from 2006. And it really started to change the way that we think about scale of information, but also about lack of maybe availability of information in certain spaces. But the truth is that when we're thinking about environmental information visualization, it is very much dependent on the type of information that we're collecting, but also who is our audience. I'm sure as students in a program that's very much dealing with design, but also interaction, one of the first questions you're asked is, who's your audience? Who are you designing for? Who are the stakeholders? So this was an interesting exercise for us to begin to maybe survey existing public and free applications that were starting to engage people with environmental data. What you're starting to see is a lot of similarities. So you're seeing some maps, some graphs, you're starting to see some very maybe large graphics. And a few of them, for instance, are starting to use icons, so a smiley face, a duck, and all of that is for us to begin to maybe pay attention, so create hierarchy of information. But an interesting survey and some literature on the way that people engage with these types of a lot of them that are citizen science apps is that a lot of people stop using them over time. At least I could attest to that. I have quite a lot of them already on my phone. So I began to really think about how do we really collect information? How do we engage with it? And as an architect, I do teach in schools of architecture. I have at least since I began, I thought that architecture is in serious crisis. So really beginning to learn from other fields and go back to architecture has been, for me at least, interesting. So as somebody who teaches a lot of sustainability courses in architecture, I begin to look at the tools that we currently use. So this is a database generated by a program called Energy Plus. For instance, at the time I was looking at information in New York State, and these information is coming from weather stations. And what we're calling weather stations are usually moments like this. So these are often placed in what is deemed as idealized locations, so places that are, let's say, safe, people are not going to maybe climb it. But as you can imagine, this is a weather station in Los Angeles. It's quite far from maybe where pollution is taking place. Now, over the years, there's been a lot of debates about not only how we collect data, but also where are these data collection points. So for instance, famously, city of Madrid had a scandal that was, I think, quite interesting, that over time, depending on who was, which politician was in the office, the location of the weather stations were changed. Also, for instance, for many years, China misreported information. Mexico also has some guilt in that. So I think it's quite interesting to, when we're thinking about information, really think about the dynamics, the political dynamics of how this information is collected. Then, of course, another way that you could also look at information collection is through, in this case, is using simulation. The problem with simulation is that if we're starting with moments like this, then probably our simulations are not correct. So for instance, going back to this list, I was teaching my students in Manhattan, very dense, very different, but then we are referencing weather stations that are quite far from where the pollution is taking place. Now, opposite of that is fieldwork. So fieldwork is something that in sciences are quite important. So you set up a sensor, you go to the site, you collect the information. However, that's very time consuming. So for instance, I was teaching a studio, a design studio in the city of Yerevan in Armenia. And the whole idea was to begin to decode some of the maps that were inherited from Soviet Union. So during Soviet Union, a lot of encryption was applied to maps. So we begin to really think about, can we begin to use existing maps and design based on that? But what we very quickly realized that if we're talking about, let's say, pollution patterns or any urban environmental issues, we don't have enough data. So instead of doing analysis, building on data that wasn't accurate, so we created a very simple mobile app which got the GPS of, in this case, students' phone, and we were begin to walk all the way around the city and collect location of the trees. So of course, when you're connecting location, you're looking at GPS, but there's other parameters as well. So general, maybe diameter of the trunk and type of the canopy. So actually, we ended up spending the entire studio collecting, in this case, data of the trees. And we were able to then share it with an environmental institute there. Now, this is not something that's very unique to a country like Armenia, which is quite small and cannot maybe afford to spend time in collection of data. I've spent a lot of my research in Los Angeles. Los Angeles is a city that its history is entangled with urban environmental issues, specifically air pollution. So here I was teaching a very short course with students at SCI-Arc, Southern California Institute of Architecture. And we tried to think about how maybe devising very low-cost sensors would allow us to walk in a specific neighborhood and begin to do, again, data collection from the trees. So we began to think about how maybe combining different views, so top view, first-person view, and at the same time beginning to plotting the information could allow us to better understand what we're looking at. Needless to say, this was, again, the entire time that we spent during the studio collecting this tree type information. So as you could see, it could be quite time consuming. So this is a chart that my colleague, Maida Yaguno-Muniza, that some of the work today focused on air quality that I'll be sharing is in collaboration with her. This is a general classification that we have devised, and we've been using it over the years. So we have generated this based on relationship of the sensor to the environment, and we're classifying this in terms of whether the information is local or remote, and whether the sensor is static or dynamic or mobile. And we begin to collect, let's say, different attributes of each of the methods. For instance, if we are looking at the weather station that I showed earlier, that's an example of local static sensing. So it has very high temporal resolution, right? It's able to collect data every few milliseconds, which is very, very good. But as you can imagine, it costs quite a lot of money to set something like that up. However, if you look at what we did with SciArc students or with students in AUA in Yerevan, that's an example of local mobile sensing. So we use affordable sensors, devices, ubiquitous devices, and by walking, using bikes, using cars, etc., you're able to cover a larger ground. But as you can imagine, that's going to have a higher spatial resolution, but lower temporal resolution, because you're not able to cover the same location many different times. But over the years, actually, we have concluded that local mobile sensing, it has not only possibility to give us a general, maybe general mapping of the space, it would allow us to not only understand the spaces that we're designing better, but also it could really create participation. Now, this is a general diagram that has been guiding a lot of the research that I'll be sharing today. So at the center of this, again, going back to the question of who are the stakeholders, who's the community that one wants to influence, then again, what is it you're collecting? It could be air. Some of the work I've been doing is about water. So what you're collecting is at the center of, again, the technology that you apply. But there has to be participation incentives. And from game theory, these are the 4 categories that I've come across and summarized over and over again. Either there is a research component, so people participate because they're interested in the research. So for instance, if you're part of an institution, you participate because you're interested in advancing the research. Or you're an activist, going back to all the applications I showed earlier, people like maybe us that maybe would show up to rallies, we would also go ahead and take that extra step to download the application. Or maybe people are interested in information. So maybe this is part of an exhibition, maybe it's part of a newspaper. We're starting to see how, for instance, New York Times has done a series of data visualization efforts, right? Or or another aspect of this could be monetary gain. So we've also seen an example of this where, for instance, monetary gain would incentivize people to participate. So from collecting maybe scooters or maybe even this conversation about value of data. So going back to, again, this quote by John Tukey, I begin to really think about how maybe this exploratory aspect could be further expanded by the use of extended reality. So whether we call it extended reality or mixed reality or virtual reality and augmented reality, the truth is that this technology have the possibility to allow interaction and immersion and activation of location, right? So this is many ways that we can talk about this medium. They could be locative media. So locative media traditionally have been associated with using of mobile devices because you're able to use GPS or VPS. They allow interaction. You're able to contribute to the environment. You're able to also take back information, but also they're immersive. And going back to the memory I shared with you earlier, the memory of being, let's say, in front of water and remembering what it was and what it became. So immersion can have an important aspect to this. So the experiment today started from this very modest attempt at mapping University of Southern California, which is where I was doing my PhD. So if you're familiar with LA, University of Southern California is on the southwest of downtown LA. And again, history of LA is pretty much defined by conversations about air pollution. So Clean Air Act was very much inspired by the pollution movement, activism that happened in the 1950s. At the same time, also the smog check that currently we have to do for our devices, this was something that was very much inspired by the pollution in Los Angeles. So the very first attempt was to use very simple electronics that anybody could use and find and assemble and create a kit that could be versatile. So a kit that you could attach to your bicycle. It has a place if you want to add your phone. And at the same time, you can flip the same kit, and this was 3D printed, and you can attach it to, let's say, something like a drone that could do larger scale of monitoring. So the very, very first attempt I asked one of my friends if he could take half of the sensor, attach it to his bike around campus, and we begin to look at, can we send that information in real time as well and visualize this? So this was a workshop that we had during a conference, Acadia conference in 2014. And we looked at how to monitor two people riding their bicycle on campus simultaneously. What you're starting to see is that here we're only plotting temperature. And of course, there's temperature change based on topography, but also there's temperature change based on density. But we realized that that's on its own was not enough. So we then started to really think about this front camera, the very simple reverse mobile capturing that you can do from front of your bike. And begin to think about, what if we take two parameters, temperature and CO2 readings, and overlay this with the video. So here we assigned a color value for temperature to be between blue and red. So blue is lower temperature and red is higher temperature, and then pixelation is the amount of CO2. So as you're starting to see here, we're leaving campus, we are going near the freeway, and pixelation is starting to change. And what we realized after some, in this case, user testing and asking questions, people begin to associate the pixelation and lack of resolution of the image to also smog. And people begin to kind of use words like, blurry spaces, or they begin to refer to adjectives that are very much associated with difficulty to breathe. So we continued that experimentation on campus and started to see some linear and nonlinear relationships. So the upper left corner, these are open courtyard, it makes sense, lower temperature, lower CO2. But then when you're starting to look at, let's say, some areas inside and outside campus, we realized that there's just too many variables. It was difficult for us to do an analysis. So what if we then look at covering a larger area? So series of experiments were done to create vertical readings using the same devices and drones. So this is a corner of one of the most, let's say, active places on campus. So this is a building, multiple stories. And we started to say, well, what if we also overlay the plot of the values next to this visualization? And actually, people begin to respond to this much better because they could start to see the change in color, but the fact that they could understand the device of data collection, in this case, drone, much better. What's great about using something that you can program, such as a drone, is the fact that you're able to control the speed, you're able to control the frequency of how many times this data collection is being done. So the same experiment was done throughout the campus. As you can imagine, getting permission for flying this drone was a story on its own. At the end, we were able to do some urban parameterizations and arrive to a general map like this. So remember when I showed you all the pixels of different moments? And what we begin to realize after a lot of interpolation and correlation, there are these couple of different moments that were important for us to study. And what we realized was this point 3 was the most polluted place on campus. That is a corner of two very, let's say, high traffic streets, but at the same time, it's near a freeway. So that makes sense. But then the general trend didn't make sense why this specific corner was too high. We began to look at surface types, number of trees, but what we realized after a while was that this high density of pollution was due to duration of the traffic light. Well, that makes sense, right? If cars are idling, of course, you're going to build up different type of gases. Now, of course, that's something that makes sense, and we've learned all this, correlations. But this is something that, without doing this visualization, we were not able to really find, and it allowed us to actually go to the provost and start a conversation about this. So actually, next semester, I am doing an exhibition which is all about the data collection on campus. And when I started my dissertation, there was, let's say, less interest on this versus now. So for instance, I was given when we applied for multiple grants for this project, I was given one of the excuses was, well, we wouldn't hate to have a visualization like this out when parents are visiting, they're dropping off their kids, right? Or then when they're visiting campus. But what if we actually think about this as something that universities or buildings or different zones can use it for their advantage? So the same research triggered series of, let's say, interest in grant writing. And this was for the first time realization that it is really important to not only do the research, but begin to communicate this with authorities or for people that actually, fortunately and unfortunately, the drive what type of research is being conducted in institutions and outside. So through collaboration with my dear Biayna Bogosian, who was at the time starting a postdoc at Princeton University, we applied for an innovation grant. And with that, we were able to create a series of experiments in the city of Seoul. What is really interesting about South Korea and Seoul, and going back, talking about the politics of this, is that for many years, Korea has blamed China for all its pollution. So it is no secret that China has contributed to, contributing to pollution as part of industrialization. China is not the only country doing that. London was the first industrial city that really began to face issues of pollution and smog, and other cities and countries have followed. But what was fascinating about working in Seoul was that the only reason why we were able to conduct this project at the time, which was for the Seoul Architecture Biennial in 2017, was that the mayor that was selected, his big promise was to address pollution of the city. So what that meant was more willingness to collaborate. So we began to work with the city official and people that facilitated the biennial to really advance what we had in terms of sensing and think about what you usually are using in a weather station, and begin to create that in a more compact way that could also have high-pole magnets that you can maybe attach it to the roof of your car, or in this case, to inner city buses. So we began a series of negotiation to begin to attach series of sensors to buses while the Biennale was happening, and do real-time data collection and visualization. So this was two of us climbing up a ladder, putting the sensor very simply on these buses, and then returning to our station and hoping it would work. What was really fascinating was that this is happening during summer, but let's say summer in California is different than summer in Seoul, and our calculations about solar panels and everything else had to be calibrated. And what we had in the exhibition space was a real-time map of 6 of these buses that were traveling at the time and visualizing the data, but also inspired by what we did in the USC experiments, 2 different mobile applications. One that begin to either tap into the nearest weather stations or the 6 sensors that we had traveling, and introduced, in this case, again, color and other variables, very, very rough prototype that we were able to finish on time. But this one took much longer, and we worked with the city to collect data from 30 years of weather stations. And at the same time, we found a way to also get real-time data from existing weather stations. That was a very interesting process, because for us to get real-time data, we actually had to, they had to make sure that we are working with a citizen of Korea. And so for us also, it was quite interesting to think about, again, who is able to access the data and what could be done with the information. So after months of negotiation, we created this mobile augmented reality, which was overlaid on this 2 meter by 2 meter map. And of course, it's very difficult to capture augmented reality in video, but let's just go with this. So Seoul has 25 different districts, and we created basically these pollution clouds above each of the districts. And well, that was also a decision driven by data available from weather stations. So in this case, you were able to isolate, and the people were able to walk over this map and look at these different pollution maps. But at the same time, This was also an exercise in getting understanding, extracting information from remote sensing, importing it to this app, or also the live mode allowed you to connect to the weather stations. So what was interesting for us here was the range of people that were interested in this experience. And we learned quite a lot by trying to communicate the relationship between archival data and also real-time data. Benjamin Bratton, who is probably somebody that some of you might be familiar with, talks about actually importance of looking at archival data in order for us to really understand the planetary scale of our issues. And what I really appreciate about his approach to archiving information is that he says that it's actually a promise to the future. Maybe we don't know what we'll do with this information, but by committing to collection of data, we are, in a sense, saying that we are open to understanding what could happen. So going back to Los Angeles, the entire time I was there as a student, I started to see that maybe there's some interest and activity over the years taking place at the university about understanding air pollution. So a USC School of Engineering, Viterbi, started to create these series of very simple sensors around campus. And this was, for them, a demo for what they created, a series as a kind of a backend for beginning to process IoT devices around campus. So I approached them and I said, well, what if we actually take this existing weather stations or these air quality sensors, they were not really all weather stations, and begin to find a way where we could create a Pokemon Go style game around campus. So for instance, what if we create a way for students to go discover these sensors and for them to maybe engage with this? So this was the general architecture that I was starting to use. So really thinking about relationship between what was existing technology. So at the time, Niantic's platform called Lightshift was not open to public. So the only thing available was integrating Mapbox with Unity. And at the same time, beginning to work with the School of Engineering to connect all of these pieces together. So this short video is our first MVP. And this was recorded right before the pandemic. And unfortunately, due to the pandemic, this development stopped for almost a year and a half. So what you're seeing here is a very simple interface, which with arrows is guiding you to the nearest weather station. And once you are able to find one, it is telling you what is inside the device. So this was a sensing kit that we put together in order to be able to communicate with the data. And once you unlock one of these boxes, then with your student ID, you're able to find more locations. Now here, what you see is drawing from what you saw earlier with the color, but here the student ID becomes a way for you to activate more locations, and then you're able to look at weekly trends. What I realized after a lot of questionnaire and a lot of user testing was that really for students, air pollution was a weekly issue because they really plan their life around their class schedule, right? So for them, maybe specifics of the day was not that important, but really maybe how they could plan their courses based on air pollution. Now, as I mentioned, this was stopped, but what I learned from here is how to engage with maybe a combination of, I'm going to go back to this, combination of not only introducing data in different rate and archival information, but also importance of really incentivization, going back to that earlier diagram. So again, we're looking at incentivization either for research, for activism, for monetary gain, or for entertainment. So the kind of conclusion of this project is now, which is a very early steps of this. So I have just been granted a 5-year NASA grant to set up a sensor, a Pandora sensor on Florida International University campus. And the reason that this is important for me is when I moved to Miami to start my teaching position, for me, selection of Miami was very much based on the urgency of environmental issues there. When I would share with my students what my earlier research was on air pollution, they would ask me, but why air? So I realized that actually students in Miami have no idea that actually air pollution is as dangerous as the floods that they're experiencing right now. So being able to bring the sensor on campus is really important. So this is part of an effort that NASA currently has to set up series of sensors around the world and begin to connect them and use this network as a way of correlating other sensors. So if you think about these sensors as a way of calibrating maybe things like this. So I'm not sure if you're familiar with Purple Air, but Purple Air is probably the most successful citizen science effort ever, not just about air pollution, but in general. What's really exciting about Purple Air, which was a startup that had a very simple goal of communicating air pollution with the public, was that they focused on particulate matter as kind of a way for them to reduce cost of these sensors, but also create an open API where people could build on. And you should definitely go and check out who in your neighborhood has Purple Air sensor. I think the spike was when California fires happened. And if you are interested in maybe how this could become a model for different cities, look at the San Francisco area and you'll see almost a station or two on every single street. And I think that's very encouraging. So what I'm trying to do is to do the same thing in Miami, which is maybe there's 2 sensors across the entire city. So I've set up a number of them on campus. This is right outside of our lab. And while I'm setting up the Pandora sensor right above this building, we are right now working with Lightship, which is an effort by Niantic to actually release the kind of the back end that makes Pokemon Go. And we're in the process of finishing a demo, which hopefully I'll be able to share very soon. So we don't necessarily need to have super high-end sensors, but if we're starting to maybe think about what is already existing and what would locative, immersive, and interactive media allow us to do, maybe we can begin to avoid things like this. So I'm sure you've heard of what is currently happening in Florida and other states. So experiencing ponding flooding is quite common in, let's say, Miami. But what is currently happening is if people are interested in getting engaged, so going back to maybe there's an activism initiative, maybe it's research. This was an effort by one of the high schools where they asked students to go and measure existing flood height. So they're using things like ruler. Of course, that's a great early step, but what was then issue was that when scientists would go back to look at the information, sometimes they would get things like 6. Okay, is this 6 inches? Is this 6 centimeters? So finding a way to take existing infrastructure such as this and introducing maybe a system for interaction could be interesting. So this is an effort that I've led since joining FIU. And every semester, I put electrical engineering and architecture students together to work on a capstone project, and every team kind of hands it off to the next one. So we have this device called Water Wand, which is attempting to collect water depth and pollution. And we are basing the sensors, and these are some of the early prototypes, on what is currently collected by the city. So we looked at many different versions. Of course, electrical engineering students are learning how to integrate sensors, and architecture students are learning how to do 3D printing, how to do drawings and representation and work together. So the goal is to use these devices in the coming citizen science initiatives, as it's absolutely critical to not only for architects to understand how to maybe design for this, but also for scientists to be able to do better simulations. So hopefully this would be something that we'll be able to release open source very soon, and it could be printed and adapted by anybody. So part of what I've been doing, and this was my goal for going to Miami, is to understand how I could take what I learned by working with air pollution data and apply it to water-related issues. I was very much curious to see what are the similarities and differences. And what I realized was that there's definitely similarity in scientists trying to communicate by citizens willing to help, but then not knowing where to start. But also the fact that there's a disconnect in the way that data was transferred, data was analyzed, and data was then passed down. So a lot of my efforts have been trying to create visualizations that maybe bring people from different disciplines and are able to put them together and for them to engage in a conversation. So this is a traveling exhibition that is in, it's a long-term research, but it's at a state where I've been able to show in multiple cities, called In Deep Water. And this is funded by National Science Foundation, and it's supported by my affiliation with Institute of Environment at FIU. And the goal was to create a traveling exhibition, whether we want to call it mixed reality or extended reality, that had many different components, and it allowed people to understand information in different scales. So for instance, our Institute of Environment at FIU goes and does a lot of community outreach. And part of that is to be able to sit down with the community, and what you see in this lower right corner, do a very typical, idea collection. But at the same time, there's efforts done when we have, for instance, instances of fish kill, which are dealing with a much more complicated data. So I'm going to skip here and share my video. I think I know that okay, great. So this component that you'll see, it's done in HoloLens 2, and start by taking a questionnaire. And I was interested in this because not only the question that you might be asking might be different in different cities, but also it allows people to be comfortable with the interface. So for instance, using sliders and touch and hand interaction is something that's quite important when you're working with specific devices. And by asking them to engage in a very simple questionnaire, they were able to learn these very simple interaction by the time they got to the experiment. Now, asking questions in virtual reality is something that's practiced quite a lot, especially if you're working with if you're working with computational neuroscience. But I was very much interested in also collecting this information and analyzing them later. So similar to what you saw in Seoul, here we have a very large image. This was also an exercise in how to extract high-resolution map images. So we were able to write a bash script to get Google Map images and stitch them together, and then using a hack in Blender, overlay the entire city to the same image. So this is a high resolution map of portion of Miami. And this space was 8 foot by 8 foot. I'm going to skip ahead. Of course, again, let's skip ahead. So you have a menu here, and one of the options is to look at sea level rise. So sea level rise is something that is the first thing I show my students in any design studio. So first, we realize how many years we have left. And it's a very striking thing because we never really understanding spatially. So here you're looking at NOAA's 100-year prediction. So every notch is a foot. It's also a decade. And this also had audio in a sense of, I'm gonna just, so I'm slightly moving here, but you should see this. So there was an audio component where linked to the height. So higher, I'm gonna skip ahead slightly. So higher the sea level was, higher the audio. It was going to be quite difficult for me to speak over it. But there was also rumble from the city. And this was a moment that was very much curated for people to bend down, press that button, and then see the city and then see the water. And of course, a lot of work was put into finding and writing a shader that could be optimized for this, along with the city, but also this was a very interesting moment because almost everybody engaged with this experiment. Then the second tab allowed them to look at existing sensors that was collecting pollution information. And what was exciting about this, on the right side, you'll see one of the examples of the buoys. So the buoys are part of, if I use equipment that's used for collecting information. And pretty much any research that I do in terms of putting devices together is based on what we're also collecting with these. So being able to understand and interact with this was important because I knew that we might have some participants that were kids. So we were, eventually this is going to be part of Miami's Science Museum. So it was important for us to think about how kids would interact with this. You were able to look at the position, the type of data based on different months, then look at the readings from the Miami River versus the Bay. So the biggest issue that a lot of environmental scientists are facing in Miami is that there's a disconnect between information that comes from salt water versus fresh water. So beginning to do a comparison and tell the public that there's actually a difference and we need to invest in maybe more sensors. And then the last one was, I'm going to skip ahead. So this one used eye gaze tracking, a capability of Hololens, and it allowed you to walk around. And when you would look at one of these images, it would give you a narrative about what the specific effort was. So for instance, this is one of the low-cost surface drones that we're working with in the back. That's an example of the water wand, which you saw earlier. And so, of course, depending on people's background, whether they were familiar with the city or not, this experience, which was about 5 minutes, took maybe people had different reaction to it. So this is very much, again, work in progress, and hoping to have this in the in Miami Science Museum in the next year. I'm going to go back to my presentation, and there's a few short projects also that I would like to share. So at the core of all of these efforts has been really looking at teaching and research as the same thing. So here you're looking at some early experiments that I conducted in Shanghai. So Shanghai has been a city that's been quite special for me in terms of not only being able to engage with different institutions there, but also as a city which has a history of air pollution. So I've been able to look at it as a comparative study. And of course, technological constraints when you're trying to do real-time data is very different, let's say, in China than here. But really thinking about how VR and AR could be a tool for not only information representation, but also teaching, and the conversations that maybe different modes trigger has been really interesting. So what you'll see here is an example of one of the experiments in virtual reality where the same kind of physical space that one was able to experience with HoloLens was replicated in HTC Vive. And here, audience were able to do teleporting, which is something that's very unique and special to virtual reality, and also be able to run simulations. So having the option to migrate between these devices, because we know that truly XR is not possible yet, but perhaps when we're thinking about our information, really thinking about what each device could afford is really important. So speaking of teaching, I'm going to end with a few short projects which they bring up other issues related to XR technology. This is a project sponsored by Stephen's initiative called Virtual Tabadul, or Virtual Exchange. And the objective here was to teach Arabic and English to 1,200 students in different locations using augmented reality. Using virtual reality. So this is a really interesting challenge, because how do you scale up the experiment? And how do you make sure that also you are within budget? So we relied on Google Cardboard, and we leverage A-Frame, which is a tool that I'm pretty sure some of you are familiar with. And we really begin to think about pushing what was currently possible with A-Frame. So for instance, we bought and sent number of 360 cameras for different people in different cities to do documentation. So in this case, from a bazaar to a classroom to, in this case, in Timgad, in one of the ruins. And really begin to think about what would be the cheapest way possible for us to still experiment with learning. So we knew that students had Zoom, and at least in this case, that was an assumption we had to make. Of course, accessibility to computer is another issue. But then what we knew was that we could ship all of these cardboards to these students. Of course, there's a large team behind this, and there's a publication that I'll mention at the end if you're interested in more of this. So we ship these cardboards to certain centers that students in Morocco, in Algeria, and a few other places could go and pick up. Then they would be paired with a student in the United States, in Miami or in Dearborn, Michigan, because it has the largest Arabic speaking community. And what we knew was that with Google Cardboard, we were able to know what the area of focus was. And then that was what was activating each clue. So for instance, here, this is a classroom in Miami, and there's a large Cuban population, and students show up to class with a cup of colada. So for instance, in this case, by looking at a specific cue for certain moments, for certain seconds, you were able to activate a clue which had an audio component that then had also other assets that could be triggered. And this was really an experiment in scalability, but of course, a very simple way of looking at eye gaze tracking, and not really eye gaze tracking, but head tracking. Then we have a PhD student that is looking at how to incorporate eye gaze tracking with the same lessons. If you're interested in perhaps thinking about not maybe specifically language learning, because I know that maybe that's not something that you're looking at, but this is a journal article that we just published, and we looks at basically virtual exchange using methods that we used. Now, of course, looking at extraction of eye gaze tracking or biometric data is something that's quite important in the field. So if you're interested in more of that, this is a grant that we had from SOM Foundation that allowed us to spend 4 years looking at relationship of neuroscience and the way that we think about cities and the way we build. So a very large portion of this was looking at the way that media such as virtual reality could allow us to extract environmental information. And this was in collaboration with UCSD's computational neuroscience department. So if you're interested in this research, this is the page. And I'm going to stop here because it would be great to hear some of your feedback and engage in a conversation with you. Thank you. Yes.
My name is David. So I guess can you go to the slide just before the video is here?
Which one? There are a lot of people with glasses. This one. The water one? Yes, the video. Yes, sure.
So, is this the screen?
Yes, this is direct capturing from HoloLens. Absolutely no editing, no input. That's why you see quite a jump, a lot of jump.
Is it exactly what
Yes, yeah. So this is what the person sees. So I can go earlier. So here, it might be actually helpful. I can also show you what the, yeah. So you're basically asked to look at the map. To begin the experience, look at the map. You look at the map. This is a two-dimensional high-resolution image, and that triggers basically the three-dimensional version of this. So this was extracted for anybody interested. This was extracted using Blender and stitched together on many hours.
Just curious, what do you think? Don't have the map with the black.
Yeah.
Can everything
Yeah, absolutely. Absolutely. So the reason for this was that with the HoloLens, there's some lag time because with HoloLens 2, actually the device needs to be calibrated for each user's eye, which is this awkward moment where you need to prepare the user for them to experience whatever you have for them. So by introducing the project, so I'm going to go back to my presentation here. You'll see the setup. So by having this map in front of them, I was very much curious to see what other conversations or information exchange could happen. So for instance, this specific instance is taking place in Los Angeles. And when I knew that I was going to do this exhibition, I thought, well, what if I show flooding in Los Angeles? Well, it really wasn't that impactful, right? So I said, okay, I'm going to keep Miami. I'm going to show Miami and LA, but then I need to prepare them, right? So then you had this series of questions. But what was exciting about this was that by having the map, people started to tell me if they've been to Miami, if they've lived in Miami. People were showing me where their parents used to live, where they've been, or they were telling me about maybe stereotypes. Or so it started to create another level of conversation that I was very much curious to hear. So this anticipation for people to first begin by looking at a two-dimensional map. Most of us actually haven't seen maps that are maybe larger than our phone or our computer screens, right? So I think this change in scale and viewpoint is critical, and that's one of the most wonderful affordances of using this technology, because you're able to shift between first person and top mode. So I was very much interested in this build up. And then after the 2D, you could see here the second image. They're asked to bend down and press this button, which then, it changes their distance to the map, right? And then you have this three-dimensional element that's appearing. Is that necessary? Of course not. There's many different ways that you can do the same thing, but I was very much interested in this kind of ritual of maybe starting a build up. This was done in, of course, what you're seeing in the background. So it was about 2 years of work, but then just this development was, I would say, solid 2 months. Yeah. And I think it goes without saying, if you saw earlier, this is very much evolution of what was shown in Seoul with, I'm gonna do this. So maybe there was very much evolution of this project, right? So again, using a large map. So this one was almost the same size, but then allowing people to walk, because you'll see towards the end of this video, certain kids were not really interested in this. They were interested in walking on the map, and what you'll see in a few seconds is the same thing was projected also in the back. Yes.
So, as you know, a researcher, anybody who's working in specifically communities that might be disadvantaged or have a harder time, what sort of continuing, relationship do you have with these communities? Do you feel like you could establish a better continuing relationships with them outside of university partners?
Yeah, that's a great question. So, you saw that I referenced many different cities, and I've tried to understand, because I think community engagement is something that we throw around quite, I think, casually quite a lot, and it's something that is, let's say, in a lot of, job applications or in a lot of grant applications is becoming a must. But I think it's quite difficult to really understand what that means and how we can contribute to that conversation. But going back to those principles of incentivization, so whether it's research, activism, monetary gain, or entertainment, I think these are ways that we can then think about then what are these really communities. But I think I'm at least like in terms of environmental issues and environmental design, people are willing and interested, at least in Miami. I think nobody is denying, climate crisis anymore. And my students, every time something like this happen, are so emotional, and they talk about how their families are also beginning to talk about this quite a lot. Of course, one of the questions I get quite a lot is the so what? Okay, we're able to look at it, but so what? But then with things like this, sure, the community can help to collect the data, but unfortunately, at the end is about who makes this decision. So the In Deep Water, which you saw earlier, I was able to demo it to the mayor of Miami, and for him, that was a little bit too complicated. But then he wasn't interested in looking at the river information or what else we've done, but he was interested in just seeing the water, and he said, okay, I can discuss this with the chief resiliency officer of the city, and I think this could be interesting. So then, of course, taking that into maybe a more a venue that's engaging kids that are younger, maybe that's a contribution I could do. But I think that's a very large question, and I think sometimes when we think about community engagement, we don't really know what the extent of our contributions might be. But I think more conversations is the only way forward. Yeah.
Any other projects that you didn't have time to discuss that you could describe?
If you're interested, just feel free to go to my website, and there's quite a lot of other ones, but I think if you like, just that's my website, and I'm trained as an architect, so I have this other life which is been building things from skate parks to interactive interior spaces, but I decided at some point to stop that component and just understand what I could learn from other fields, and then decide what I could contribute back. But a lot of it has been in teaching. So with my students at FIU, we've been able to enter EPA competitions and place nationally. So that's something that I'm proud of. So I think at some point, it's as part of interdisciplinary research, is also important to kind of scale back and say, at least I'm doing this for the next few years and see if I can contribute, and then move again. Thank you.